So today we're talking about log functions. The nice thing about log functions, you've already dealt with them before. N equals b to the L. So if we have exponential form, you guys would be like, oh, that's no problem. I know what exponential form is. Some base to some power. And then what we can do is we change L. That changes N. The base usually stays the same. Then we also learned log form, where the log L is equal to log base b of n. Remember, if you can notice that they are interchangeable, that the base stays the same, and the way we have here is the log equals L. And L in the exponential is the exponent because logs are exponents. Okay, so I'm going to give you guys two different graphs here. One, n equals 2 to the L. We're not using x's and y's, we're using n's and l's to kind of keep with the same letters we have here. And if I go to log form, it would be L equals what? What would that be in log form?
Log 2 to the n.
Log 2 n. Okay, now if I remember correctly, did we graph logs?
No.
We didn't?
No.
I thought we did. Maybe we didn't. But we graphed exponential functions, and we graphed those, and those kind of looked like this, right? Especially if 2 was bigger than 1, or bigger than 1, which means it's exponential growth. And what happens if I went and said, hey, 1, 2, 3 over, and I go up to the graph here, and I told you that was 8. Would that make sense? 2 to the third power is equal to 8. That would make sense. Granted, my lines are not very straight. It's not very drawn to scale very well. Well, if I went over to my log graph, log graphs all of a sudden look like this. It's kind of like they got flipped and turned on its side. And the really cool thing about it is that if I go over 1, 2, 3, 4, 5, 6, 7, 8 and run up, I end up at 3. So now I'm putting 8 in and I get 3 out. Because 3 was the exponent to make the base 2 equal to 8. That's how the nice thing about log graphs is that you can use either one to solve for the unknown variable. Okay? That's kind of just what we're just kind of highlighting that fact that I could and remember they're set up differently, as in we have L on the bottom here where we have N on the y-axis, but over here we're putting in N and finding L on the y-axis. So you're starting with different variables to get the other variable. So what are we doing then? We are going to develop the rules for logs. We're going to develop the rules for logs. You guys know the 3 rules. We'll get to those in a second. Would you guys agree that log base 10 of 10 squared is equal to what? What happens when the bases are the same? The answer ends up being 2. Right? Basically, you're asking yourself, because they're interchangeable, 10 to the second power equals 10 squared. And is that true? Yeah. Okay. We also then should know that log base 10 of 10 to the third power is equal to 3. Okay. Using the same technique of switching it to exponential, and then I can solve it. You guys then should also agree that 10 to the third power times 10 to the second power is equal to what? Exponent rules. 3 plus 2. So would that mean, that would mean that log base 10 of 10 to the third times 10 to the second is equal to what? Wait a minute. We know some rules on this. What would that rule say that if I had things multiplied?
You sum the choice?
I can separate them with addition. So therefore this would equal log base 10 of 10 to the third plus log base 10 of 10 squared. And wait a minute, log base 10 of 10 to the third is actually what? 3 plus 2, which is 5. Interesting. What was the exponent? What would this end up being up here? That'd be 10 to the 5th. Interesting. Remember, logs are exponents. So do we have that written down? We also have the same idea, 10 to the third over 10 squared. What would we be in exponents? You would say what? That'd be 10 to the... What would this be? 10 to the 3 minus 2, which is 10 to the first. So what happens if I put a log in front of that? Log base 10. 10 to the third over 10 squared. Now, when you split them to their own logs, you separate them with subtraction. Log base 10 of 10 to the third minus log base 10 of 10 squared, which is 3 minus 2, which is 1. Same thing happens when you use exponents, or power of power. What about this one? What do we do here?
10 to the 6.
10 to the 3 times 2, which is 10 to the 6. What if I put a log base 10 on the front of all of that? What happens with that 2?
It becomes log 8. No, it goes in front of log.
2 log base 10 of 10 to the third, right? Wow. Which is 2 times 3, which is 6. So it all works very nicely. Now, what happens if I just take all the numbers away? What if I asked you this? I gave you some background information. I say let M equal B to the A. And N equals B to the C. So, two exponent or exponential forms. Two different exponents, right? With their values. If I switch both of those to log form, what would they look like? Log base B of, you gotta switch them to log form. Log base B of M equals A. So log base B of M equals A, because remember, log equals the exponent. And this one would be log base B of N equals C. Can you guys agree with the switching of both of those? So if you're given all of that, can you prove this? Prove this formula? Show me that. Show me that it works. Show me that it should be log base b of m plus log base b of n.
Plus or multiply?
That's a multiplication.
Oh.
The dot originally there wasn't very dark. So let's just use simple substitution. I'll do the first one with you. On the second one, I want you guys to try on your own. Would you guys agree that I could change the m and the n to their exponent form? Like the exponent, they're equal to something, right? Could I change that to b to the a times b to the c? Was that okay? M equals that, n equals b to the c. That's good. Now we got exponents. What do we do with the exponents when we got the same base? And we're multiplying. We add them. So this becomes log base b of b to the a plus c. Whoa, wait a minute. We got a base, log base b of b to an exponent. By this, what's going to happen? They cancel and you're left with a plus c. Ooh, let's go back and substitute what a equals, what c equals. And you find out it ends up being log base b of m plus log base b of n. Isn't that the formula? The rule? We just proved it. We just created it. Now, I'm going to turn the page. You're going to have to still use the same information up here, though. Prove this one. Whoops, that's bad. Prove that one. I'll pause it. I'll give you guys some time. What's the next step?
Log base b.
Log base b of
A, or b to the a minus b to c.
b to the a
Over.
over b to the c. Now you have it set up so that you have the same bases being divided, so you do what to their exponents? Subtract.
Why did you switch to a and c?
I mean, why did I switch a and c?
Like, why you don't use m and n?
Because I'm substituting using the information that we had before, so that it works. So we actually set up the same base. Because right here, they don't look like they have the same base.
But couldn't you wait too?
Weight as in...
Like you use the M and the N and then you just change it in the
Whoa.
You can't, well, see what the thing is that we're not trying to, we can't use the formula that we know of separating with subtraction. We had to prove that it works. So you can't just say, oh yeah, I can split that and then go to the other. No, no, no. We had to switch it to common bases so that you get the fact that it's b to the a minus c.
Don't ask me to do it again though, because I can't.
So therefore we can show that it works.
Wait, so if we didn't have like our problem before this, we couldn't have solved this problem?
We're not actually solving the problem, we're actually
Okay.
showing that it
Yeah.
does work.
But since we wouldn't have the information, like of the,
If I didn't give you what m and n
Yeah.
equaled and switch it, then yeah, you can't do that.
so if we just, that was like our first problem, you never gave us the other stuff, we couldn't really solve this.
Right. You would have to know the information, and I'll go back.
Of, like,
You need
what
to know
M and
this
N
information.
equal.
You'll be given
Oh.
something like this, and it'll say, show me this works. So we did the first one, now we're on to the second one. And now, since you got your b's the same, therefore you end up with a minus c, and a was just log base b of m, and c is log base b of n. And
Just N minus N? Oh wait, never
Oh, no, I got it now.
mind.
Wait.
so that it just proved it.
Oh.
So log base b of m over n is equal to log base b of m minus log base b of n. I'm just showing that the top part here that we started off with would come along for the ride and it would equal that. That is the property that you guys learned several lessons ago.
Question.
Yes.
Is that the first part? Is it log b?
And the last one, obviously, is show this. Show this. I want you guys to try this one on your own. Okay, so first thing we got to do is we need to get rid of n. And so this becomes log base b of, what was n? That ended up being b to the c?
Oh, so you do B to the C.
X, right?
E to the X to the Y.
Now, if I remember correctly, this would be a power of a power, and what would you do to the exponents?
It would be C times.
Power of a power, you multiply. So this becomes x to the cx, or b to the cx, sorry.
Wait, but they cancel.
They don't cancel. No, they will cancel. What do you mean by cancel?
It'll end up being equal C to the X.
Yeah, then it just equals c to the x. Now, x was our constant. There was some number. So generally when we see these types of things, we put them in front of our variables. So would it be okay if I put xc? Is that okay? Same thing? Now the reason I'm doing that is because x isn't going to change, but I know what c is. C is
Log B N.
log base b of n. So notice that the exponent of x got to go out front, and it's multiplied. Okay? That's what you guys are going to have to do. In your homework, it's going to ask you to do something like this. Of one of them, I think you should practice all three, because I am going to put them all three on the quiz. I'll probably change up the variables.
What happened to C?